Hello, let's continue our Sudoku adventure with Dominoes by Strosahl. So this is just a pure killer today. So let's go over the rules though. We do have normal 6x6 Sudoku rules, meaning in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have cells in the grid surrounded by dotted lines. These are called cages, and there's always a value in the top left of the cage, and that tells you the sum. So these two digits, because they're the two digits in the cage, they sum to 9. So we could do, for example, 4 or 5. It's one way to do it. And that's it. Those are the only rules. We don't have any givens, so we have to use the sums of these dominoes in order to solve the puzzle. All right, there's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. So there's a little trick with dominoes that looks like it comes up quite at least 2 times in this puzzle. So specifically with dominoes that share a row, column, or box, right? So you can't repeat digits between them. There's if they have consecutive sums, like this 5 and 6, like this 8 and 9, they always kind of affect each other and prevent certain combinations from working. But before you go and like fiddle around with like case checking, the first thing I would check is, like in this case, we have 4 cells that need to sum to 11. Because we know these two sum to 6 and these two sum to 5. So these 4 sum to 6 plus 5, which is 11. And I know that in 4 cells, there's only one way to make 11 if we can't repeat. So how would we discover that though? Well, first we want to think about what is the minimum we can put into 4 cells. The reason I'm using minimum is because it's so close to 11. And so 1, 2, 3, 4 is our minimum. And 1, 2, 3, 4 adds to 10. Always good to know your triangle numbers when doing sums in Sudoku. And so 1, 2, 3, 4 sums to 10. And we're trying to get to 11, which means one of these digits needs to increase by 1. But we're not allowed to repeat any digits. So the 1 can't increase to 2, we already have a 2. The 2 can't increase to 3, we already have a 3. The 3 can't increase to 4 because we already have a 4. So the only digit that can increase is the 4. It's got to increase to 5, and now we know this is the only way we're adding to 11. And now we can kind of inspect things and figure out which digits go where. Because if we want to add to 5, we can't use a 5. So the 5's removed from here, meaning there is a 5 in here. And what goes with a 5 to add to 6? Well, the 1 does. And then what goes with the 1's removed. So 2, 3 adds to 5. So that's one way to deal with it. For the 8, 9, we're going to deal with it in a different way. Because 17 is kind of a middling sum for 10 digits. For 4 digits. You can think about how 3, 4, 5, 6. Well, the triangle number for 6 is 21, and we're removing 1 and 2 from it. So 21 minus 3 is 18. So actually, no, 17 is big. Okay. So we can do the same trick, but let me just show the other way we could do this anyway. I forget which one's good to look at, but for the 8, our options are either 2, 6, or 3, 5. Right? We're either going to do 2 plus 6 or 3 plus 5. But for the 9, our options are 3, 6, or 4, 5. Now, if you inspect, you can see actually there's an issue with 3, 6, because 3, 6 uses one digit from one of our pairs and another digit from our other pair, right? If we do 3, 6, we can't do 3, 5 to add to 8, and we can't do 2, 6 to add to 8, so we wouldn't be able to add 8 at all. And so we end up with this being 4, 5, and that removes the 5 from here, which also removes the 3. And actually, if we were to think about it, 2, 4, 5, 6 would be the only way to add to their total, which is 17. So 2 ways to accomplish the same result. If we look at these dominoes here, they sum to 12. There's 2 ways to sum to 12, but it might be easier to think about what's left behind by the sum to 12. So this is what we call outies. So we know the entire row sums to 21 because the triangle number for 6 is 21. 1 plus 2 plus 3 plus 4 plus 5 plus 6, 21. And that's what's placed in this row. If we subtract 12 from that, we end up with 9. So these two sum to 9, which is really interesting because you can kind of think about how there's a virtual killer cage that spans these 2 cells that sum to 9. How are we going to sum to 9? Well, there's only 2 ways. There's 3, 6, and 4, 5. There's a problem with 4, 5, though, which is that this would create 3, 4, 5s in the same column. There's not enough digits for that. So this has to be the 3, 6. Very nice. And now we can think about the outies here as well. In fact, the 3, 6 can only go one way because of the 2, 3 pair. So that's 6 and that's 3. We have 3 in the corner. And so now we can just finish this column. We need a 1 in the column, and this column needs a 4. Very nice. And so now we need to add to 7. We can't do 1, 6, and we can't do 3, 4. So we have to do 2, 5. And then the remaining digits are going to be 3, 6. Very nice. Cool. This is neat. The other thing we could have thought about is there are only 2 digits, even without this 4, 5 pair. There are only 2 digits there are 2 digits you can't put in a 6 sum. You can't put a 6 in a 6 sum, and because it was already too big, right? 6 plus 0. You also can't put a 3 because you can't repeat the 3. So the 3 and 6 had to get ejected out of these two cages. All right, so what are we doing next? We got the entire border except here. So the way we're adding 6 is 1, 5 or 2, 4. I'm trying to think if 1, 5 or 2, 4 is problematic. This we cannot add to 9 using 4, 5 because we'd have 3, 4, 5s in this box. That wouldn't work. We'd be able to stretch them too thin. So this has to be 3, 6, and that removes the 6 from here. So that's 2 and that's 6. Oh, the 2, 5 did something similar. I didn't notice that. 3, 6, 4. Okay. So what does this get me? Because of this 3, 6 pair. So the roping, right? We know this is 3, 4, 6. So this is going to be 3, 4, 6. And this 3, 6 pair says 3 is not there. So that's 4 and that's 3. This is 1, 4, 5. The 1's in one of these two. It's the one over here. If this was 1, this would be 5. I think that works. How about this 5 sum? It's either going to be 1, 4 or it's going to be 2, 3 like that. So where's the 6 in this box? It's in one of these two. That points up, giving us the 3 and the 6. All right, and we know this is 1, 2, 5. Gotta have eagle eyes for this puzzle. 1, 5, 2, 4. So not 3. 1, 5 or 2, 4. This is the other one. So it's either 1, 5 or it's 2, 4. That's the only way that works because of this 4, and then the ones are here. So this is 1, 2, 5 column. This makes a 1, 4, 5 triple. So this can't be 5. So that's 2 and that's 5. There's a 1, 2 pair here. 4, 5, 1, 2. We're missing the 6. Yeah, and these 2 digits are these 2. Okay. Wow, interesting. I feel like I'm just something like obvious that I'm missing, but I'm not seeing it. Keep looking to see if there's 1, 2, 4, 5. What's next? I don't even know what I would pencil here. Is there something? 3's in one of these 2 cells. That's a bit interesting. I wonder if it has to do with like one of these choices or one of these choices. I mean, if this was 2, 4, it does make this a 3. It's 1, 5 though. Pretty open. What am I missing? This could be 1, 4 or 2, 3. Oh, it can't be 2, 3 because of this 2, 3 there. That's the issue. So that places the 3 in the box, and that's our 2. That's 1 and 2. That's 6 and 3. That's our 6. The 1, 4 pair makes that a 5. That's 1. Clean this up. This is the other digit. This is a 2. Giving us 5 and 2. All right, that's what I needed. I can't believe I've missed that so long. This is a 1-4 pair, so that's 1, that's 4. 1 plus 5 is 6, that's a 4. Get a 5 and a 4, we get the 1 and the 4 and the 1 and the 5, and our last digit's the 3. We're done. All right. Yeah, I somehow just, even though I saw it several other times in this puzzle, I somehow missed that 2-3 breaks that cell. I mean, it's a 5 cage here and a 5 cage here. I should have realized they had to be 2 different 5 cages, but I didn't really see that for some reason. Wasn't even that much to look at. All right, well, is what it is. I hope you enjoyed this. If you did, then why not leave a like, subscribe, and a kind comment below.